Okay, question 16. A company makes monsters. Well, I don't really care if it does or it doesn't. The company makes small monsters with a height of 20 centimetres, and that is shown in this picture. So this information really, I don't like it in words. I've got a picture, it tells me the height of a small monster. So I'm just going to say this is small, just to connect the two. It says a small monster has a surface area of 300 centimetres squared. So I'm going to just do that in brackets. The surface area is 300 centimetres squared. It then says the company also makes large monsters with a height of 120. It then says a small monster and a large monster are mathematically similar, and this has got to trigger something in your memory. This is a key part of the question. I've got to work out the surface area of a large monster. So I know if I'm going from small, I enlarge it, I go to large, this is going to be increased by a scale factor. And I can work out the scale factor by looking at the lengths. I've got a height here of 120 and a height here of 20. So the scale factor to go from 20 to 120, if I use my fingers, 20, 40, 60, 80, 100, 120. It's been increased by 6 times, so the scale factor is 6. I then go back to this important part here, mathematically similar. I know if the ordinary scale factor is 6, then the area scale factor is the ordinary length scale factor squared. It's always squared. So that means the area scale factor is 36. I have got to find the surface area of the large one. And I know the surface area is equal to 300. So if I times this by the area scale factor, if I times it by 36, that will give me the surface area of large. So now I've got to remember how to do 300 times 36, but it's easiest to do 3 times 36 and then add 2 zeros on the end. So 36 times 3, 6 times 3 is 18, 3 times 3 is 9, and if I add the numbers inside the box I get 8, 9 and 1 is 10, 0 down, carry a 1, 0 and 1 is 1. So it's 108, but I've got to add these 2 zeros on the end, so it's 108 and 2 zeros on the end.